In this video, we're going to talk about sales tax, markup, and discounts. And this is the typical problem that we will be solving during this video. We have a $120 computer game and a 5% sales tax, and we're asked to find the final price. There are two ways to do these problems, and in this video, I'm going to review both methods. The first method is to find the adjustment amount and then apply that adjustment amount to the original price. The way we apply the adjustment amount is predicated on what type of problem we are dealing with. Specifically, if we are dealing with a sales tax situation, we are going to add the adjustment amount. So our intuition tells us when we see the word sales tax that our final price is going to be higher than the original price. So let me show you the process. First, we establish or we document the original price, and to find the adjustment amount, we apply the percentage to this original price. We use the decimal form, and we use multiplication because in math, of means multiply. So we take 5% of $120 to get $6. We go back to the problem and we remind ourselves that we're dealing with a tax. Therefore, we're going to take this $6 amount and we are going to add it to the final price to get a $126 amount after the sales tax is applied. So let's review what we just did. Here are the particulars of that problem. Original price, $120. We're dealing with 5% and we're dealing with a tax. We find the adjustment amount. To do that, we take the percentage and we convert it to a decimal. We multiply by the original price. We get the adjustment amount of $6. Since we're dealing with a tax, we're going to add it to the original price to get a final that is higher than the original. Next problem, $90 pair of jeans, discounted 30%. That tells us our final price is going to be lower than $90. The original price is $90. The adjustment amount, we take that percentage, we convert it to a decimal form. We multiply by the original price of $90, gives us the adjustment amount. We go back to the original problem. We remind ourselves we are dealing with a discount. That means we're going to take the $27, subtract that from 90 to get a final price of $63, lower than the original price. Again, find the adjustment amount, subtract it from the original price. Another example, $50 scarf, 20% markup. That tells us that the final price is going to be higher. Here's your original price. The adjustment is found by taking the decimal form of the percentage involved, multiplying it by the original amount, and that gives us an adjustment amount of $10. We then ask ourselves, what are we dealing with? Answer, markup. Therefore, we add that adjustment amount to the original to get a final price of $60, which is higher than the original. This is a two-step problem. Namely, the first part deals with the discount, and the second part deals with a tax. Again, first part is a discount, second part is a tax. So, quite simply, we're going to do this in two steps. So in step one, we have a $100 original price. We're going to find our adjustment. We're going to apply the 20% in decimal form, multiply it by the original price of 100, and get the adjustment amount of $20. Since in part one we are dealing with a discount, we're going to subtract that $20 from the original price and get a final price of step one for $80. Now, when we move to step two, interestingly, the final price of step one becomes the original price of step two. We go through the same process. We deal with a 5% sales tax, so we multiply 80 by the decimal version of 5%. That gives us an adjustment amount of $4. In part 2, we're dealing with a tax. Therefore, we take that $4 and we add it to $80, and we get a final price of $84 after both steps of the problem are completed. Now let's move on to method 2, and I find this to be a better method. Recall, that in method 1, we use the adjustment amount. Here in method 2, we are not going to use that. Rather, we are going to use a formula that's going to take us from the original price directly to the final price. And here it is. New, meaning the final price, equals the original price times 1 plus or minus r, where r is the decimal form of the percentage you are dealing with. Now, we're going to use the plus version of the formula when we're dealing with a situation where the final price is going to be higher than the original, namely a tax, tip, or markup situation. When the price is going to be lower, namely with a discount, then we are going to use the minus version. This is the type of thing that becomes more clear when you do examples. Here's our first example. We have a $15 coat with a 20% markup. Our intuition tells us that we are going to have a final price that's going to be higher. Therefore, we use the version 1 plus r. We convert r, namely 20%, to a decimal. We add that to 1 to get 1.20. And here's where I feel this formula is very intuitive, because 1.20, as you know, is the decimal form of 120%. Here, we're not paying the original price. Indeed, because of the 20% markup, we're paying 120% of the original. So that's why we're multiplying 120% in the form of 1.20 times the original. Again, very intuitive. Next, we're going to substitute $15 for the original price, and our final price, or new price, is going to be $18. Here's another example. $30 item, 10% discount. Because the word discount is in the problem, we know intuitively our final price is going to be lower. We're going to use the 1 minus r version. We're going to convert 10% to 0.10. 1 minus 0.10 is 0.90. Again, very intuitive. This is the way we write 90%. We are not paying 100% of the original price. Because of the 10% discount, we're paying 90% of the original price. Again, that is the way to do these problems, in my opinion. We substitute $30 for the original, and we get a new price of $27. Here's a two-step problem, and this formula works very well in this scenario. Now, it's very important, ladies and gentlemen, not to add these percents, or combine them, I should say. That's not how you do these problems. You have to go through the steps as outlined below. Here, we have a two-step problem. The first part involves a discount. Therefore, we're going to use the 1 minus r version for that portion of the problem. And step 2 is a 5% sales tax, so we're going to use the 1 plus version of the formula for the tax part of this problem. Here, we place the numbers. Here's our 40% discount. We subtract that from 1. Here's our 5% sales tax. We add that to 1. We then plug in our numbers, and we get a final price of $252. One step, very efficient. To me, this is the way to do these problems. Okay, let's do a few more examples. We start out with a jar of pickles that is $14.50. So that is our original amount. We're dealing with a markup. Therefore, we are going to use the version of the formula where we're going to do 1 plus the decimal version of R. So that's going to be $14.50 times 1 plus 0.30. Again, we are not paying 100% of this price. Indeed, we are paying 130% of the price. And when you do the math, you get a final price of $18.85. Again, it makes sense to us. It's a markup. It's going to be higher than the original. Here, we have concert tickets for $100 and a discount of 21%. Therefore, we know that the final price is going to be less than the original. We're going to use the 1 minus R version because we're dealing with a discount. We have $100, 1 minus the decimal version of the percent that we're dealing with. That's going to give us 100 times 0.79 because we are only paying 79% of the original price, not 100%. And that's going to give us a final price of $79. Now, one little aside here. This subtraction, where you're doing 1 minus 0.21, it's not very intuitive. So don't hesitate to take this 0.79 value and add it back to the 0.21 just to make sure you did your math correctly. Don't be too proud don't be too proud to say that you know you did it correctly in your head. Go back and check your math. Here we have a belt. $19.99 original price. We're dealing with a tax. Therefore, we're going to use the version where the new price, is going to be the original times 1 plus the decimal version of the percent that we're dealing with. So that's going to be $19.99 times 1.02, and our final answer is going to be $20.39. Again, makes total sense intuitively. You have an original price, you're adding a tax, the final price is going to be higher. Okay, here's a two-step problem. We have an original price of $29.95. We have a markup. Okay, let's do this as we go. New is going to equal original. For the markup, we're going to do 1 plus 0.20. And for the sales tax, we're going to do an up again of 0.02. Again, ladies and gentlemen, do not combine these percentages and do it in one step with 22% markup. That's not how it works. You have to do it as I've outlined. Okay, the original price is $29.95. We're going to multiply that by 1.2, and then we're going to multiply that by 1.02. Again, this is for the markup of 20%, and this is for the tax of 2%. When we do that and we do our math, we get a final total of $36.66. We have a hat, $10.50. We got a discount, and then we got a sales tax. So we're going to put the original price. For the discount, we're going to use 1 minus 0.55. For the sales tax, 1 plus 0.06. 1 minus 0.55 is 0.45, and 1 plus 0.06 is going to be 1.06. And again, ladies and gentlemen, here, this is not an intuitive subtraction right here. Don't hesitate to come to the side and add 0.45, 0.55. Check your math. Don't be too proud. When you do that and you plug in 1050 for the original, you do your math, you're going to get $5.01 for your final price. Okay, so let's review. In method 1, we found the adjustment amount. We used that adjustment amount to find the final price. Depending on whether it was a tax situation or a discount situation, we would either add or subtract respectively. Second method is the formula method. It's the method I prefer. This slide looks busy, but in my opinion, this formula simplifies things, and that's the way to do these problems. We're going to end this video with this beautiful picture of Dartmouth Hall, located on the campus of Dartmouth College in Hanover, New Hampshire.